Year 12 probability today, and we want to start off with tree diagrams, right? Tree diagrams. They look like a tree. They don't join up, they fork, they split, they don't join up again. That's really what makes it a tree. So a little bit of language to begin with this topic, right? We're talking about events, right? If I'm talking about an event, that is a combination of none, one, or more possible outcomes. Yep. A multi-stage event, there is more than one different sort of game or experiment, right, that contributes there to that event. We talk about outcomes. That's what can happen if I have a list of all possible outcomes. That's called the sample space. The list of all outcomes. The sample space, the size of the sample space, is the number of outcomes in that list, is all it goes. So I've got a tree diagram here that talks about what might happen, or demonstrates what might happen if I flip 3 coins, or I flip a coin 3 times. So we start sort of here. Yeah, that's before I've tossed a coin. Now, toss the coin, there are 2 things that can happen. It could be heads or tails, right? There are 2 paths that we could go down here, right? So heads or tails. If the first one is head, it could again be a head, or it could be a tail. Right, if the second one's head, it could be a head again a 3rd time, or a tail the 3rd time, and so on. Right? That gives us 2, 4, 8 possible outcomes at the end, from all heads to all tails, and the other permutations in between. We're going to learn about these words, permutations, combinations, but not today. So, list of outcomes is the sample space. The number of outcomes in that list is the size of the sample space. If I want to know the probability of some event occurring, right, it's the number of outcomes that belong to that event divided by the total number of possible outcomes, divided by the size of the sample space. Here's an example. Now, this is slightly different to the example we looked at there before with the flipping the coins. This time I have some numbers. They're on cards, they're placed into a box, and I take 2 out, one after the other. Importantly, we've got to read these very carefully. Importantly, I can't choose the same number twice, because once it's been taken out of the box, it's no longer in the box, it's no longer an option. So we're going to take 2 out to form a 2-digit number. The order that they are placed down is going to be important as well, and that's something we need to think about all the time. But my first stage could be either a 5, a 6, or a 9. Right? We see there are 3 possible outcomes for the first stage. Now, if the first one is 5, then the second one can't be a 5. It could only be a 6 or a 9. Right, so this could be 6 or it could be 9. If I draw a 6 first, it could be a 5 or a 9 second time. And if it was a 9 first, then it could only be a 5 or a 6 the second time. Okay. So there is my tree diagram, and I should really list the sample space here at the same time. So that gives me 56, 59, 65, 69, 95, and 96. There are exactly 6 outcomes there in my sample space. Okay, that's this part done. Have I answered that? Have I drawn a tree diagram? Yes, indeed I have. To list all possible outcomes, I have done that too. Great. There are some other questions to go with this. Calculate the probability. Now remember, probability is the number of desired outcomes, the number of outcomes that belong in that event, divided by the total number. So there are 6 here. How many 65s are in this list? Exactly 1. So the probability, let's say, of 65, I can put it in brackets like that. That's one way of writing that. The probability of 65 is 1 over 6. Right? There is 165 on the list over 6 possible outcomes. Now, odd numbers. Not this one. I've got 1, 2, 3, 4. There are 4. So my probability of odd equals 4 out of 6. And of course we know, being good math students, that we write that as 2/3. Wonderful. Greater than 65? Well, 1, 2, 3. Probability, say, greater than 65 is 3 over 6 equals 1/2. Yep, and divisible by 5. I have 1, 2. Probability of 0 and mod 5. I don't know. I'm just going to say P. Probability of divisible by 5 is we said there were 2 of them out of 6 equals 1/3. There we go. We've got 4 different answers. How interesting. Right, tree diagrams. That's all you need to know for them. Right, tree diagrams for multi-stage events. Hope you've enjoyed it as much as I have. Check out the next video.